Hello students, I am Professor Navneet Kaur from EC Department, SIRT College, Bhopal. Today I will be taking lab lecture on subject digital communication. In this experiment, I will be discussing program for Matlab code to generate amplitude shift keying signal. Now first we will see the aim of the experiment. The aim of the experiment is write a Matlab program to generate carrier modulated signal by amplitude shift keying, that is ASK method. First we'll see the theory of this experiment, in which we will discuss about amplitude shift keying method. Amplitude shift keying is a form of modulation that represents digital data as variations in the amplitude of a carrier wave. In ASK system, the binary symbol 1 is represented by transmitted a fixed amplitude carrier wave and fixed frequency for a bit duration of dB seconds. But if the signal value is 0, then no carrier signal is transmitted. Any modulated signal has a high frequency carrier. So the binary signal, when ASK modulated, gives a 0 value for low input, while it gives the carrier output for high input. We can see the concept of ASK modulated waveform in this figure. Here we can see the message signal, which is represented by 0 and 1 bits, where 0 is represented by 0 level and 1 is represented by positive level. Now we have ASK modulated output wave here. When the message signal is 0, the modulated signal is represented by signal of 0 voltage. Whereas when the message signal is 1 bit, then in that case, the modulated signal is represented by a carrier wave of frequency Fc. So here in this case, we can see the ASK modulated output wave, where 1 is represented by carrier wave and 0 is represented by no signal. On-off keying denotes the simplest form of amplitude shift keying modulation that represents digital data as the presence or absence of a carrier wave. The presence of a carrier for a specific duration represents a binary 1, while its absence for the same duration represents a binary 0. Now here in this figure, we will see the block diagram of the ASK modulator. Now here we have a mixer circuit in which two inputs are given. One input is given in the form of a message signal, which is unipolar binary sequence generator. Unipolar signals means it has signal of only one polarity. That means 0 signal is represented by 0 voltage, whereas 1 bit is represented by a, a signal of positive voltage. The second input is carrier signal, which is a sinusoidal high frequency. When these two signals are given to the mixer circuit, the output generated is the ASK modulated signal. Now, ASK modulated signal is represented by V ASKT, which is given by Bt into cos omega Ct, where omega C is the frequency of the carrier signal and Bt is the unipolar message signal. So here we can see when Bt, that is the message signal, is 1, in that case VSK will be given by cos omega Ct. So here we can write VSK is given by cos omega Ct. That means it is represented by a carrier wave. Whereas when Bt is equal to 0, the modulated signal is represented by no signal. Now here we will see the Matlab code for the generation of the ASK modulated signal. Now first thing, we will enter the carrier frequency. So for that we will write the code F is equal to input, enter the analog carrier frequency in Hertz. When we will run this command, it will ask the analog carrier frequency in hertz. So here the entered value is 1000. Then we will specify the parameter on the x-axis, which is time parameter t. So it is given by 0 is to 1 upon 512 is to 1. This means that the range of t is from 0 to 1 with an interval of 0 is 1 upon 512. Then I'll represent the message signal, which is, the carrier signal, which is given by x is equal to sine 2 into pi into f into t, where f is the carrier frequency, which was mentioned in the first command. And this is a carrier, which is a sinusoid of higher frequency. Then we will introduce the message signal, which is the binary data. So for that, I'll write the command I is equal to input, enter the digital binary data. Now it will ask the digital binary data. So I'll write it in terms of as a sequence of 1 and 0. So here I have written binary data as 10111010. Now capital X represents the ASK modulated signal. Initially, I'll take it as a null matrix. Now, for generation of the ASK modulated signal, I'll write a program in a loop. For small n is equal to 1 is to length I. That means I will write a parameter n which will start from 1 and end up to length of I. I is the digital binary data. That means it here I have written 7 samples in I. So length of I means 7. That means small n will take value from 1 till 7. So all the 7 samples will be considered for small n. Now, if in is equal to 1 and n is equal to 1 means that if the first sample is being taken and the value of that sample is 1, in that case, what will happen? We will have, for first sample, we will have carrier wave as the modulated signal, and the rest of the signal will be the ASK modulated wave, which would have been previously considered. So it will be written as capital X is equal to small x, which is represented by a carrier frequency, comma, capital X. Else if, that means second condition is taken, that is if in is equal to 0 and n is equal to 1, which means that the first sample of binary data is considered and the value of that sample is 0. In that case, there will be no signal for the first sample and the rest will be defined by the ASK modulated wave, which would have been previously considered. So I'll write capital X is equal to zeros, 1 comma length x. That means here we will have a matrix which will have one row and number of columns which will be defined by length of x. So whatever the number of the samples are there in X, there will be as many columns and all the values will be having 0 value. So initially, since the first binary data is 0, so there will be no signal for that sample and rest of there will be defined by the ASK modulated signal. Now the third condition, else if in is equal to 1 and n is not equal to 1. That means here we are not considering the first sample, we are taking sample other than first and the value of that sample is 1. In that case, I will write ASK modulated signal as capital X, comma, small x, which is represented as the carrier signal. Then the fourth condition, in is equal to 0 and n is not equal to 1. That means I am considering sample other than 1 and the value of that sample is 0. So in that case, the value corresponding to that sample will have a modulated signal which will be represented by no signal. So capital X will be represented by capital X, zeros, 1 comma length x. That means it is defined by a matrix which is having row 1 and the number of the columns as the number of the samples in x. So all these samples will be having value 0. So I will end the loop. So end for right, for closing this else command, and this end is for closing the for command. Now I have three signals with me. One is carrier signal, message signal, and the ASK modulated signal. So I will plot all these three signals. Now subplot 3 comma 1 comma 1. That means I have defined a figure window which is having three rows and one column, and my first signal will be placed at the first position. Plot t comma x, where x is the carrier signal, x label t, y label xt, and title will be given carrier signal. So here the carrier signal will be drawn, which will be a sinusoid of higher frequency. Then I'll plot the message signal. For plotting the digital message signal, which will be in the form of a 1 and 0, I'll use the command stairs. So subplot 3 comma 1 comma 2, that means my digital data will be placed in position 2, stairs I. For labeling the signal, I will write X label T, Y label IT, and title will be message signal. Now I'll plot the ASK modulated signal. So subplot 3 comma 1 comma 3. That means my message signal will be my carrier signal, my modulated signal will be placed at third position, and plot X. So for labeling, I'll write X label T, Y label ST, and the title will be ASK modulated signal. Now these are the waveforms which will be generated after running the command. So here I can see the first waveform represents the carrier signal xt versus t, which is a sinusoid of higher frequency. Then second waveform is of message signal. Here I can see for first sample is 1, then 0, then 1, 1, 0, 1. That means here the 1 is represented by a pulse of positive polarity and 0 is represented by pulse by 0 voltage. Now here it is ASK modulated signal. We can see that when the message is 1, in that case the ASK modulated signal is represented by the carrier wave. Whereas when the message is 0, the ASK modulated signal is represented by no signal. So here we can see the ASK modulated signal, which represents the carrier wave for binary 1 and no signal for binary 0. Now this is how we generate our ASK modulated signal using Matlab. Now this is all for today's lecture. Thank you.